entropy is a measure of possibilities. It's the number of possibilities that the atomic arrangements called microstates of a system can be arranged so that the system looks like it does and has the properties that we measure, which we call the macrostate. You can arrange atoms lots and lots of different ways in a system without changing what we see at the macro level. If there are more ways to arrange the atoms, we say that there's more entropy. Next, we will look at two fundamental laws from thermodynamics about the way our universe works. The first law states that energy can neither be created nor destroyed. It is always conserved. For example, we can touch two objects together that have different temperatures and different energies. When the objects touch, energy is transferred from the hot object to the cold object until both are at the same temperature. If you calculate the energy of the system in the end, it will exactly match the energy that it had before contact was made by the objects. However, this law is not sufficient on its own, since it doesn't prohibit a transfer of energy in the reverse direction. For example, you can take two objects of equal temperature that are in contact, and you could imagine that one of the objects could heat up to a higher temperature while the other loses heat to become colder. Yet this doesn't happen in reality. We only see energy flow from hot objects to cold ones, not the other way around. Clearly, we're missing something. That would be the second law of thermodynamics, which depends on the notion of entropy. The second law states that the total entropy of a system can never decrease. In the example of the hot and cold objects, when the hot and cold objects are separated, they have lower entropy than when they are connected. Why? Well, the colder object will increase in temperature, giving its atoms more motion and more possibilities to rearrange themselves and increase entropy. The hotter object will lose that energy, but it will not lose as much entropy as the colder object has gained. The entropy of the system overall is larger. Hence, the second law of thermodynamics ensures that heat flows from a hot object to a cold one and not the other way around.